Hi students, welcome to our channel. In this video, we are going to discuss what is meant by time complexity and how to measure the time complexity. In previous video, we have discussed what is space complexity and how to find the space complexity for the given algorithm. If you have not seen that video, so please watch that video. So now we will discuss what is meant by time complexity. Time complexity mainly depends on the total time required to execute the program. The total time required to execute the program. That means here, so while discussing this space complexity, so mainly it is depending on here two types. One is fixed part and another one is variable part. Variable part is nothing but here this is independent variables and this is dependent variable. So like that, here time complexity mainly depending on instance characteristics. Instance characteristics is nothing but, so here instance characteristics is nothing but dependent variables. Is nothing but, so we have to concentrate mainly on what are dependent variables in an algorithm and how many times each statement is executing. So how many times or in how many steps or in how many times each statement is executing. Each statement is executing. That we have to calculate. After that, we have to add for each and every step how many times, and finally we have to add to get the total number of steps. We will get the total number of steps. Okay, so this will become the time complexity. So this we will calculate by using one variable. That variable is count variable. This process is also called as step count method to measure time complexity. Step count method to measure the time complexity. In that step count method, we will take one variable, that is count variable. Initially, that count variable is 0. Assume this is declared as global variable. And for each step execution, count will be incremented by 1. For each step execution, count will be incremented by 1. For each and every step, count will be incremented. Totally how many times that statement is executing, those many number of times this count will be incremented. Okay, so now how to find out time complexity by using this method. For example, I have an algorithm like example for finding time complexity. For example, I have an algorithm to find sum of array elements. Algorithm to find the sum of array elements. I already said to you that time complexity and space complexity you can calculate correctly if you have written algorithm correctly. Then only you will get a correct time complexity. Okay. But for this already we have calculated space complexity and already we have written the algorithm also. Now for the same algorithm, now we want to calculate time complexity. So remember that time complexity mainly depending on dependent variables. Remember, so time complexity mainly depending on dependent variables. Dependent variables. Okay, so now what is the algorithm for this? So first we will start with algorithm. Array sum of array elements, array sum. The parameters here required are a comma n. Then sum equal to, we have to initialize. This algorithm already we discussed in space complexity video. Please watch that video if you have not seen. So sum equal to 0. This is the algorithm I am writing. So for I equal to 1, 2, n, do sum equal to sum plus I. Sum will be calculated and finally we have to return sum. Okay, so this is the algorithm. For this we are applying count variable. For each and every step we have to write count variable. Okay, so how to write? So for this I am writing here. For this, for each and every step you have to write a count variable. Incrementation. So for this statement, count equal to count plus 1. Again, for loop, again count equal to count plus 1. For each and every steps we have to write. Okay. For this sum addition or some calculation also we have to increment count variable. Count equal to count plus 1. Again for return sum, count will be incremented. Count equal to count plus 1. So for each and every step you have to increment count variable. Okay, so now what we have to do is we have to count how many times each statement is executing. Suppose this statement is executing one time. Initially, what is the value of count? Initially, count value is 0. This is executing one time means a count will become 1. Count will become 1. So how many times this will execute? This will execute one time. Now, so this first statement is not executing one time. This first statement will execute for n times. Why? Because if n equal to 3, I equal to 1, I equal to 2, I equal to 3. Then I equal to 4 condition will fail. At that point also, this statement is executing. So plus 1. So this is for true case. This is for false case. That means for loop condition is failed. Now when this statement will execute, whenever this condition is satisfied, like I less than or equal to n. That means how many times this statement will execute? So n value 3, then this executes 3 times. N value 5, so this executes 5 times. That means how many times this will execute? N times. Like that, this will be repeated, and whenever the condition is failed, execution comes out of this for loop. Then how many times this sum will be returned? Only one time. So only one time. Add all this. So n plus n, 2n plus 1, 2, 3. 2n plus 3. So finally, what is the value of count? Finally, the value of count is 2n plus 3. Then how can you see the time complexity? The time complexity you can say as we have to ignore the less powers of n and we have to ignore the coefficients. Then we have to consider only n powers. Why? Because time complexity mainly depending on instant characteristics. That means only dependent variables. Okay. So now based on n only the time complexity varies. So that's why here the time complexity of sum of array elements is order of n. So the constant you have to ignore. Okay. This is one example. Next, another example. This is example number 1. Take another example. Suppose matrix addition. What is the time complexity of matrix addition algorithm? Matrix addition algorithm. So now, you know matrix addition algorithm is simply the logic is Cij equal to Aij plus Bij. Is the simple logic for matrix addition. The same here we will write. Algorithm, matrix addition, algorithm name is matrix addition. Now, how many matrices are required? 3 matrices are required. A, B, C, it is output variable. Now, another condition for matrix addition here it is, both the matrices orders should be same. If A matrix of order 2 by 3, B matrix of order also 2 by 3 only. Then only you can add. Suppose A matrix order is 2 by 3, B matrix order is 3 by 2, you can't add. So assume, while writing this algorithm, assume orders are same. Orders are same. That's why A, B. That's why here I am taking M, N only. Why? Because the same orders for A matrix and B matrix. Okay. So now how to find out matrix addition? So for I equal to 1, M is for example rows, N is for columns. For I equal to 1, 2, N, do. Next for J equal to 1, so number of rows M, 2, N, do. This is for number of columns. Then finally, how to write? This is Cij. So in the algorithm you can write like this, Cij equal to Aij plus Bij. Close this, close this. Okay. So if you know the algorithm, then only you can calculate time complexity. Remember, otherwise you can't calculate. Okay. So finally, if you want to return Cij, you can return. Otherwise, simply close this. Now what we have to do? Now we have to introduce the count variables for each and every step. So the count variables are here if you introduce. Now see. For this statement, count incrementation, count equal to count plus 1. For this statement also, count equal to count plus 1. For this also, count is initially 0 and which is declared globally is our assumption. Okay, count plus 1. For each statement you have incremented count variable. Okay, so now what we have to calculate is how many times these statements are executed. Okay, so now this statement will execute m times for condition true plus 1 is for false. In the previous example we discussed m times the condition will be true, that last time is condition is false, that time also this statement will execute. So m plus 1. Next, this is called as outer loop. This is outer loop and this is inner loop. Now for each value of I, j condition will be verified, no? Suppose that means for I equal to 1, for example m value 2, n value for example 3. Then I value 1 for this, n value 3. That means j value equal to 1 will execute, j value 2 will execute, j value 3 will execute, j value 4 which is condition failed. Now similarly I value will be incremented, I equal to 2. For this also again j equal to 1, j equal to 2, j equal to 3, then j equal to 4 which is a condition failed case. That means for each value of I, j will execute how many times? N value 3. But how many times it will execute? N plus 1 times. For each value. That means I value 1, I value 2. That means M value 2. 2 values. That means how many times this will execute? M into N plus 1. This is N plus 1 times. This is N plus 1 times. How many N plus 1 times? What is the value of M? Those many number of N plus 1 times this statement will execute. So, M into N plus 1 times. Okay. Then, how many times this statement will execute? This will not execute, right? Because condition failed case. That means instead of N plus 1, it executes M. So, M into N. M into N. That's it. Okay. Now, this is M plus 1. This is Mn plus M. This is Mn. So, totally 2Mn plus 2M plus 1. Number of times count will be incremented. Okay. Now here what shall we consider? These constants we have to ignore. The coefficients we have to ignore. This lowest we have to ignore. So the time complexity you will get. This coefficient also we have to ignore. The time complexity will be order of Mn. Suppose if it is instead of Mn, if it is a square matrix, then n is enough. And here it is n is enough. Then here what we will write is here n plus 1, n into n plus 1, here n square. Then the time complexity is add this. So here n plus 1, here n square plus n, here n square. Then the time complexity is 2n square plus 2n plus 1. So ignore lowest powers, coefficients. The time complexity of matrix addition is order of n square. Okay, hope it is clear, students. Matrix addition. If you observe the concept here, If we are using one loop, the time complexity is order of n. If we are using nesting of two loops, then the time complexity is order of n square. If we have nesting of three loops, then order of n cube. If there are no loops are not there, generally the time complexity will be constant. If no loops. So constant means order of 1, you can say. If only one loop is there, then the time complexity of order of n. If two nested loops means a for loop consisting of another for loop. For loop consisting of another for loop. In this situation, order of n square. Nesting of three loops. Three loops means three for loops. For, again for, again for. Then close all this. Okay. So now see, here I am saying only nested. For example, if the case is like this. For, again for. This for is not inside this for. Then the time complexity is n variable only. Now I am saying here nested loops. In the nested loop concept only the time complexity order of n square. So like this you can calculate time complexity by using step count method. Hope you understand, students. So if you have any doubt, please send your doubt in the comment box. If you like the video, please share with your friends and subscribe the channel. Thank you, students. Have a great day. Bye.